Hi guys, we'll be doing class 12 integration today. So this is chapter 7 of the book and we're gonna start with exercise 7.1, right? So I'm gonna walk you through a step by step of each question so you can understand it better, right? So I'm gonna start with the first one, right? So an important thing to note before starting the first 5 questions is that I'm assuming you're already familiar with what an antiderivative is, right? So it's what you, it's a function which when you differentiate, you get the original function back, right? So for example, um, the antiderivative of cosine of x, I'm so sorry, x again, right? The antiderivative of cosine of x is sine of x, right? Because when you differentiate sine of x, you get cosine of x. But you also know that this can be um, there's a lot of functions with sin x and a constant which will give you cos x back on differentiation. So what we do is we add a plus c, right? When we're talking about the family of um, integrals. But in the first 5 questions, it says find an antiderivative. So you can find any antiderivative. It does not matter what antiderivative you find, and therefore we don't need to add a plus c in the first 5 questions. So with that in mind, I'm gonna start with the first question. It says sine 2x, right? So we know that the antiderivative of sine x is negative cosine of x. And normally you would add a plus c, but since I said don't need to add a plus c, we're not going to add it here. So, because when you differentiate negative cos x, you get this. But then we see that the argument here is 2x. So if you had differentiated sine 2x, you'd get 2 cos 2x, right? So it's different from if you just differentiate sine x because you also multiply by the derivative of the argument according to chain rule. So in antiderivatives too, you do have a chain rule. It's often called the inverse chain rule because if you see here when you differentiate, you do it according to sine 2x and then you multiply with the derivative of the inside. So in integrals, what you're gonna wanna do is you're gonna want to divide by the derivative of the inside, right? So if it's sine 2x, I know that the antiderivative of sine x is negative cosine x. So I'm gonna write negative cosine 2x. And then, like I said, you wanna have the reverse chain rule. So if you were differentiating, you'd multiply it by 2 in this case. And now you're integrating. So you're gonna wanna divide by 2. And that is, I believe, the answer. Right, that is the answer. And there's no need to add a plus c here because you're meant to find any one antiderivative. And this is an antiderivative. Okay, so next question, I'm gonna move on to, let me pick a different color real quick. Yeah, so the next question I'm gonna move on to is cosine of 3x. Right, similar, this question is pretty similar to the first, and what you're gonna want to do is the same thing, right? So cos x, the integral of cos x is sin x. So for cos 3x, it will be sin 3x, and then due to the inverse chain rule, you're gonna want to divide by the derivative of the inside, which is 3. 3. And that is the answer. right? So these two questions are pretty similar, them just concept building questions. Not gonna come in your exam, but it's important you know them, right? So the third question is e raised to power 2x, right? You know the function e is a special function because both its derivative and its integral is itself. So for e2x, we're gonna write the same thing again, and then again the inverse chain rule says that you must divide by the derivative of the inside. So in this case, the power is 2x. So the derivative of 2x with respect to x is of course 2. And oh, I'm sorry, you're gonna wanna write dx each time, right? So you're gonna wanna divide by 2, and that's the answer. So now for the fourth question, which is this, right? So what you're gonna want to do is in integration you always wanna expand and get it in terms of either addition or subtraction because then you can integrate separately. So what I'm gonna wanna do is I'm gonna expand this. That gives you ax plus 2axb plus b square. Not started integrating yet, I've just expanded it. Now we're gonna use the power rule. I hope you know what the power rule is. I'm just gonna write it here with respect to x. Right. So I'm gonna use the power rule separately for each of these terms. So we know that a square is a constant. So that's gonna stay as it is. And then for the x, you're gonna wanna use the power rule. So x, then you add 1 to the power. So it goes to 3, and then you divide by the new power. So 3. Then you're gonna wanna do the same thing here. You know that 2ab is a constant, so I'm just gonna let it remain. So 2abx squared over 2 plus b squared x over 1, right? So that's gonna, if you simplify this, that's gonna give you that. And it's important to note that some of these answers may be different to what's the answer given in the back of the book, but indefinite integrals or the integrals which do not have a bound here can have multiple answers, right? So this answer is 100% right and you will get marks for it. All right. So the next question then, all right, so the next question then is sine, okay, I want to integrate sine of 2x plus 4e 3x with respect to x. So since this is a subtraction sign in between, we can just integrate separately. So I'm going to integrate separately. For sine 2x, it's going to be negative cosine 2x and the inverse chain rule again. So you're going to want to divide by 2. And for 4e 3x, right, there's a minus sign in between. So what you're going to want to do is the 4 remains as it is and e 3x. And again, the reverse chain rule. So you're going to divide by 3. And I believe that is the answer. Yes, it is. All right. So from the sixth question onwards, we need to find the family of integrals because we're not asked to find an antiderivative, we're meant to find the general antiderivative. So we're always gonna add a plus c. If you forget this, you'll lose marks. So please remember to write plus c, right? So the sixth question is the integral of 4e 3x plus 1 and dx, right? Since this is a plus sign again, you're gonna wanna integrate separately. So 4e to the 3x, you're gonna wanna write the 4 as it is, then the e 3x because you don't integrate the coefficient, and then you're gonna wanna use the inverse chain rule again to divide by 3. And for the 1, this can be thought of as 1 to the like this, and then we're gonna wanna use the power rule. So well, it just becomes 1x over 1, but I'm not gonna write the ones. So it's just an x plus c, and that is your answer. All right. Then for the next question, what we have is an x square and a 1 minus 1 over x square dx. So a general tip for integration is that you're always gonna wanna expand stuff out so you can express it in terms of addition or subtraction, and then you can integrate separately. So in this case, we can see that it's being multiplied, right? It's being multiplied. So you're gonna expand that. You're gonna multiply x squared to both of them. So what you're gonna get is x squared, and then this x squared and that x squared cancel. You just get a minus 1. And then a dx. And you're gonna use the power rule here. So x, and then for again, the 1 can be thought of as 1 x to the power of 0, which is just when you use the power rule, it's just this. So that gives you x. So x to the third over 3 minus x plus c. Yep, that's right. All right. Um, moving on. And we have the eighth question. Oh, I'm sorry, why didn't switch color? Right. The eighth question is ax squared plus bx plus c dx. Well, it's important to note in this question that a, b, and c are constants. They do not have to be integrated using the power rule or any other such trick. And well, we're integrating with respect to x. So the power rule again, for ax square, we're gonna be ax cube and then divide by the new power, bx raise the power by 1 and divide by the new power, raise the power by 1 and then divide by the new power, which is just 1, so I'm not gonna write it, and a capital C for the constant of integration. That's about it. All right. Then okay, for the ninth question, says 2x squared plus ex dx. Right, so you're gonna want to use the power rule again here. So raise the power by 1, divide by the new power. And for e to the x, the antiderivative is just e to the x. It's going to remain the same. And then a plus c. That's the answer. Right. And for the 10th question, okay, this is the first question I would um, think is slightly important, right? So it's root x minus 1 over root x squared dx. So like I told you before, in any case, in integrals, you always want to expand as a general thumb rule, right? So you're going to want to expand this by opening the square. Now started integrating it. So this squared will be just x and plus 1 over x minus 2 root x times 1 over root x dx. As well, this just cancel. So what you get is x plus, this can be written as x to the negative first power, and this is gonna be 2 dx. Then we can just integrate separately since it's all plus and minus now. For x, it's gonna be raise the power by 1 and then divide by 2. Then for, we know that the integral of 1 over x is log mod x plus c. This is because when you differentiate log x, you get 1 over x. So this is the only case where we can't use the power rule because it leads to a denominator of 0 if you check it out. If I try to use the power rule, um, that gives a situation of this, which is, you know, right. So it's gonna be log of mod x and minus 2x and plus c. That's the answer. Alright, so I'm gonna move on to the next question, 11th question, which is x cubed plus 5x squared minus 4 over x squared dx. So in questions like these, what you're gonna wanna do is you wanna give the denominator to each of those terms separately. So you can have three individual terms and you can easily apply the power rule in this case, right? So we're gonna wanna integrate. So if we give x squared to the first term, which is x cubed, so it will be just be x. And for 5x squared upon x squared, it will be just be 5. And minus 4 upon x squared, so that I can write that as minus. Yeah, like this. Right. And then I'm gonna wanna integrate separately. So raise the power by 1, divide by the new power, raise the power by 1, divide by the new power, which is just 1, and raise the power by 1, divide by the new power. So that's just gonna be a plus sign here because it's gonna be a minus 1. I'll just write it. And yeah, so we're gonna just clean it up. That is the answer. Yes. And for the next question, Let me pick a different color. Okay, I will go with this. Right. The 12th question is you're gonna wanna integrate from you're gonna wanna integrate this. Right. So again, you wanna distribute the denominator to each of those terms separately. So it's gonna be well. We know that we can just write this as x cubed plus 3x plus 4 over x to the half power dx. So I'm just gonna so x, you know that by the laws of exponents, ab upon ac is ab minus c. So in this case, it's gonna be x cubed minus half. It's gonna be 2.5. I'm gonna write that as 5 by 2. Then for 1, it's the 3x to the first power, and we're subtracting half. It's gonna be the half power. Then for 4, it's gonna be 4x to the negative 1 by half power dx. Then you're gonna wanna use the power rule separately again. So for x to the 5 by 2 power, you're gonna wanna add 1. When you add 1 to 5 by 2, what you get is 7 by 2. So x to the 7 by 2, you're gonna now divide by the new power. Then again for this 1 by 2 plus 1 is 3 by 2. So 3x to the 3 by 2 over 3 by 2. Then you're gonna wanna add 1. So it's gonna be just a half. Then divide by half plus c. Then you're gonna wanna simplify this. So it becomes, well, this 2 goes up. So 2x to the 7 by second power over 7. Then this 3 and that 3 cancel, and this 2 jumps up to the numerator. So this becomes this. Then this 1 is just here, and the 2 goes up. So 8, and then x to the 1 by 2 power can be written as root x plus c, and that's the answer. Right. So I hope I'm going at an okay pace. So the 13th question is the first question in which we won't, in which we'll have to do something other than the power rule directly. So it's gonna be x cubed minus x squared plus x minus 1 over x minus 1 dx. Alright, notice here that you can't just um, divide the numerator because it's just not a single x. There's an x minus 1. If you're gonna wanna do that, you're gonna have to give an x minus 1 to each term, which is of no use to us. So what we're gonna wanna do in such questions is think back to previous classes, and we wanna factorize the numerator. So somehow maybe we can cancel the denominator with the numerator and get something which we can apply the power rule on. So I'm just gonna do it at the side, right? So I'm just gonna take the numerator and I'm gonna think, how do I factorize this? When it's 4 terms and when 3 of them contain x, usually you have to take something out of the first 2 terms and the second 2 terms separately. So I see that in the first 2 terms, the largest factor can be an x square. So I'm just gonna try with an x square. So what that leaves from here is x. From here it leaves a minus 1, right? You can see what's in the bracket matches that exactly. So it's just a 1 and x minus 1. And you can expand that out and you will get that back. So that's how you know it's correct. And then you're gonna wanna replace in the integral. And then, oh, of course, you wanna group these together like this, right? So you're gonna put that into the integral x squared plus 1 x minus 1. Don't forget the dx. And then x minus 1. Then this and this gets cancelled. So you just have an x squared plus 1, and then you can use the power rule on it. So increase power by 1, divide by new power. Increase power by 1, divide by new power, which is just a 1. So I'm not going to write it. We add a plus c. And that, I believe, is the answer. Yes, it is. All right. Then the 14th question, which is, well, if my pen will work, it's 1 minus x, or integrate 1 minus x root x dx. Again, you're gonna wanna multiply this out so you can get it in two separate terms, which will both be separated by a plus or minus. So you can integrate separately. Just gonna do that. Integral sign gives you root x. I'm sorry. And this is just an x with first power, and it's multiplying with an x of the 1/2 power. So we know when xa times xb, that's equal to xa plus b. So in this case, it's x to the first times x to the 1/2. It's going to be x1 plus 1/2, which is x3 over 2. Right, and this is just, well, I'm gonna write it as x to the half power. And then you're gonna use the power rule again separately. So x to the half, you're gonna add 1 and then divide by the new power. That will give you this, right? And then again, so you add 1 to 3 by 2, you get 5 by 2. And x to the 5 by 2 upon 5 over 2 plus c. You can leave it here, or if you're gonna wanna clean it up, then you're gonna wanna kick the denominator of the denominator up. That is the answer. Right. So for the 15th question, right, for the 15th question, okay, so it's the antiderivative of root x, I'm sorry, 3x squared plus 2x plus 3 dx. So again, you're gonna wanna expand this out so that you can integrate separately. So this is, you know that root x is just x to the half power, and according to the laws of exponents, we'll just add the powers, right? So this gives you 3x squared plus 1 by 2, right? So that's just a 5 by 2. You can confirm it on the side if you'd like. Right, so that's a 5 by 2. So 3x to the, we're not integrating it, by the way, just distributing. So we're not gonna divide it, right? Then a 2x, so first 1 plus 1 by 2, that's 3 by 2. 2x, 3 by 2. Then 3x 1 by 2, because that's a 0, so you're going to add 1 by 2. And that is your integrand. And you're going to use the power rule separately again. So 3x 5 by 2, add 1, 7 by 2, divide by the new power. So 7 by 2, I'm just going to write it directly this time. Then add 1 to the power, 5 over 2, 1, 5 times 2, because the denominator gets kicked up to the numerator. And again, 3x 3 by 2, 3 times 2, and a plus c. So I'm going to multiply this out now. 6x 7 over 2 over 7 plus 4x 5 over 2 over 5. Then this 3 and that 3 cancel. 2x 3 over 2 plus c. That is the answer. Right. Moving on. So the 16th question reads, 2x minus 3 cosine x plus e to the x dx. Right. So I'm gonna wanna use the power rule directly this time, separately, for the first term. So it's 2x to the first power. So you're gonna wanna add 1 to the power and divide by the new power. Then you're gonna wanna write the coefficient separately. And for cosine x, we know that this is equal to sine x plus c. So for negative 3 cosine x, it's going to be negative 3 sine x. So we're going to write the plus c at the end anyway. Then for e to the x, it's going to be just e to the x plus c. Then this 2 and that 2 cancel. Just x squared minus 3 sine over x. Sorry, sine x plus e to the x plus c. Right. So for the 17th question, I'll pick a different color. Right. So the integrand is 2x squared minus 3 sine x plus 5 root x dx. So we're going to use the power rule for the first term. So that's 2x to add 1 to the power, divide by the new power. Then we know that the antiderivative of sine x is negative cosine x plus c, right? And there's already a negative sign here. So it's going to cancel out eventually. So minus 3, the coefficient remains the same, and then minus cosine of x. Then this is 5x to the half power, so you're going to add 1 to the power. So that gives you 3 by 2, and then you're going to divide by the new power. And you add a plus c, right? So I'm going to write it neatly. 3 cosine x as 10x to the 3 by 2 power over 3 plus c. Yep, that's it. Then for the 18th question, it's gonna be sec x plus tan x, right? So again, you're gonna wanna always, as a thumb rule, you're gonna wanna expand the integral, or the integrand, I'm sorry. So you're gonna write it as sec, you're gonna wanna give this sec x to both of these terms. So that will give sec square x plus sec x tan x dx. Then we know that the integral of sec square x is tan x, and for sec x tan x it's sec x. And we know this because when you differentiate tan x you get that, and when you differentiate sec x you get sec x tan x. So we're gonna write it, we're gonna use these properties that we know, we're gonna write it as tan x plus sec x plus a c, and that's the answer, right? So, and for the 19th question, we have sec square x over cos x square x dx. Okay, alright. So whenever you see sec or cosec or tan or cot, it's a good idea to usually express it in terms of sine and cos because we know so many properties pertaining to sine and cos and they work with each other really well, right? So I'm just gonna, so we know that sec square x is 1 over cos square x and sine, sorry, and cosec square x is 1 over sine square x, right? So I'm just gonna write it like that. It's the integral of 1 over cos square x divided by 1 over sine square x dx. Then you flip this around so you get a sine square x upon a cosine square x dx, which is a tan square x dx, right? But till now we don't know the integration of tan x, so much less for tan square x. So what we're gonna do is we're gonna express this using one of the three identities we learned in class 12. So we know that sec square x minus tan square x is 1. So from here tan square x is equal to this, right? So we're gonna write it as that, sec square x minus 1 dx. And then we know that for sec square x, the antiderivative is just tan x. Then for 1, for minus 1, we're going to just use the power rule. And it's going to be divided by 1, but you needn't write that. So it's just tan x minus x plus c. Right. I hope you understood this step. We're just using the identity to express it in two separate forms because we don't know the integral of tan x yet, even though we'll learn it after this exercise. This color is not nice. Right. So I'm gonna, the 20th question, which reads 2 minus 3 sine x over cosine square x dx. Right. So in this case too, you're gonna wanna distribute the denominator because if there's a single term in denominator, you can easily distribute it and get separate terms to integrate. So 2 over, so it's gonna be, for the first term, it's gonna be 2 over cos square x. I'm just gonna write that as 2 sec square x in the numerator because we know that 1 over cos square x is sec square x. Then I'm gonna write for the second term, it's gonna be minus sign, right? For the second term, it's gonna be this, writing cos square x separately. So this and that is gonna cancel to form a tan x, and this is gonna go up to form a sec x. So it's gonna be 3 tan x sec x. because sine over cos is tan x, and just the reciprocal of cos is sec. I'm gonna write it as 3 sec x tan x, then the dx. Then we know that the antiderivative of sec square x is tan x. It's going to be 2 tan x. And for sec x tan x, it's sec x. Sec x plus c. Right. That's the answer. Okay. Then for question 21, so for question 21, it's going to be root x plus 1 over root x. You need to find the antiderivative of this. Then again, we're gonna wanna write this as in the form of L the powers. We do have options, by the way, in this question. If you don't have an NCERT in front of you, it's an MCQ, right? So we're gonna wanna write this in terms of powers. So x1 by 2, and this is gonna be x to the negative 1 by 2. I hope you understand why. Because when you push that up, it's gonna be x to the negative 1, and then the square root is half power, so it will get multiplied. So x negative 1 by 2. Sorry about that. And it's with respect to x, of course. Okay, right, we're gonna use the power rule again. So add 1 to the power, divide by the new power. Right. And then do that again with this. So add 1 to the power, so it's gonna be x to the 1 by 2 divided by the new power. Then we add a plus c. Right, so the answer is gonna be, we push that up, 2x to the 3 by 2 over 3 plus 2x to the 1 by 2 over 1, that's going to be plus c. So you're going to want to match this to an option, and if you just see the NCERT, it matches to option C. So the answer for this is option C. And for the last and final question, this is a different kind of question, right? So there's going to be a new concept, well, it's going to be at the end of this chapter, which basically says that differentiation and integration are opposite processes. So what this means is, if you have a function, this is also known as the fundamental theorem of calculus, by the way, but if you have a function f of x and then you differentiate it, right, then then if you integrate the derivative, you're gonna get the function again. So essentially, or you can do it conversely. If you integrate f of x and then you differentiate the integral, you're just gonna get an f of x. So what the 22nd question is, I'm just gonna write it down. It's saying that the derivative of f of, sorry, it's saying that the derivative of f of x is equal to 4x cubed minus 3x to the power 4, and that it's also given that f of 2 is equal to 0, and then we need to find f of x. So like I told you, we're gonna use, well, this property in particular. So we're gonna, to get the original function, because we know that the value of f of 2 is 0, we're gonna get the original function, so we can plug in 2 into the x's and then equate it to 0 to find the function, right? So we're gonna integrate both sides. So what we're gonna do is, we're gonna integrate the left and we're gonna integrate the right. I'm just gonna write it as 3x to the negative fourth power. Right, so when integrating, you know that this and this essentially just cancel out and you just get f of x. So the f of x is equal to the integral of this. So you're going to use the power rule. Raise the power by 4 and divide by 4. Sorry, raise the power by 1 and divide by the new power. Then raise the power by 1 and then divide by the new power plus c. So we're going to clean that up. So f of x gives you x to the fourth power plus x to the negative third power plus c. And we know that f of 2 is 0, so we're going to plug in with 2 gives you 2 to the fourth power plus 1 over 2 to the third power plus c gives you 0. That's just 16 plus 1 over 8, c equals 0. So we're going to take the LCM of the first two terms. That's going to be 128 upon 8 plus 1 over 8 plus c is 0. I'm going to take these two to the other side. That's going to be a negative 129 over 8. So the function then is, well, this, where the value of c is negative 129 over 8. The function finally, if I write it over here, is x to the fourth plus 1 over x to the third minus 129 over 8, which corresponds to option A in the NCERT. So that's the answer, it's option A. And that's a wrap for the first exercise. Let me know any feedback you want me to change anything for the next exercise. And I too am a student like you, and I just wanna help people learn because I know it's very important, right? So if you have any suggestions on how to improve or what I can change, let me know in the comments down below. That's about it. I hope you enjoyed.